So on this one, they give us the following infinite sum from 1 to infinity of 2 to the n over 3 to the n minus an n. Okay? So what we have here now, what we're going to be doing, this is kind of like the third kind of comparison test, or the third test that we're doing here, is I'm going to implement the limit comparison test here. So our a sub n is going to be this. So 2 to the n over 3 to the n minus n. And our bn, this is where we get creative, remember? So bn is 2 to the n over 3 to the n. And now you might be wondering, why did you just like pull this out of thin air, or where did that come from? Like, how did you see it? I mean, there's no like standard rule for creativity, I guess you could say, especially like for making up sequences and stuff. But what I would say is that this, you kind of pick easy sequences to compare your given sequence with, so that it simplifies the problem. So as far as this one, for example, b sub n, I can tell that this is going to, because this is the same thing as 2 over 3 to the n, right? So you can tell just by experience that this is a geometric series. So these, we know how to deal with these already. So it's kind of like, I just made up this sequence in particular so I could utilize some of past knowledge that I have. So you just kind of look for that, and with more practice, you'll become more familiar with seeing certain things and knowing what to compare what with. So moving on. So we're using, like I said, the limit comparison test. So we have big L equals limit as n goes to infinity of an over bn. So then we're going to replace these. So we'll have limit as n goes to infinity of an. So this is going to be 2 to the n over 3 to the n minus n, over bn, which is now 2 over 3 to the n. Whoa, I wrote a 2. Okay, to the n. And now I'll flip them. I'll flip the bottom fraction up. So then we have 2 to the n over 3 to the n minus n times, and then I'll just separate it again, just because it's easier, because then we can cancel these two, right? The 2 to the n's cancel, which is good. And then we have that, I'll rewrite it down here. So what we're left with, essentially, is limit as n goes to infinity of 3 to the n over 3 to the n minus n. So, in essence, this minus n here, this little term, that's kind of going to become insignificant. So this is going to be roughly 1, basically. So limit is going to equal 1. I don't know if you can see that, but as the n, because n is the power, or the exponent on the 3's, that's going to grow a lot more quickly than the n by itself will. So that kind of just becomes insignificant. So the limit is 1, so big L equals 1, which by the limit comparison test is greater than 0. Well, that's always true. And this means that, well, from here we say that, okay, I'll write it on the next slide. Okay, I'll just carry on to the next slide. So what we have is that we found that L equals 1, which is greater than 0 at all times. And the other thing that we know is that this series, the one that I picked, the bn, b sub n, so here's where this comes in. This converges. So we know that this converges because b sub n, so this sequence is geometric, and furthermore, we know that this common ratio, or that's just another word for r equals 2 over 3, which is less than 1. So that means, by the rules for geometric sequences and series, that this converges. So, here's our big so. By the limit comparison test, okay, then our initial, like our original sum, of 2 to the n over 3 to the n minus n must also converge. Okay? All right, now moving on to 11.4.